Hi folks, we have found it. The microscope that should not exist. It's incredibly useful, incredibly easy to use, and it is cheap. The whole thing with lights and the built-in TV screen, 120 bucks. So if you use cutting tools, run a machine shop, I would highly encourage you to pick one of these up. And let's walk through some of the reasons we use it and some of the modifications and things that we've done to help minimize the Chinesium nature of this thing and turn it into an even more useful tool. No question, the most common thing we use it for, end mills and cutting tools. So we have a 1/64 end mill here. I think it's 2 flutes. If we're gonna use this tool, it's really helpful to try to see what the flute condition is. The first major modification that we made is we 3D printed this fixture. It allows us to hold different diameter end mills at 2 different angles and rotate them. We'll put the CAD model for this up on the NYC CNC website, so download it, print your own. You don't have a printer, you can have it printed online. We normally just use it real time in person, but we're gonna hit the record button to record everything we're doing here to the SD card, which is 1920 by 1080. So if you have experience with microscopes, you know they can be really particular or difficult or fussy with a bunch of things. The focal length, getting the image that you're trying to see, the 3-dimensional nature and depth of the tool, the focal length on a traditional binocular style like this one. Everybody has their own different eye relief. And so we've used microscopes for years, and this is like a breath of fresh air. I put the tool on there right away. We have it in focus. They do have this large focus ring. You can adjust the fine focus on. And then there's a digital zoom. Obviously it's just a digital zoom, so it's cheating, but it actually still helps. So here we'll jump from the normal range of 1x to 2, 2.5, 3, 3.5, all the way up to 5. And you still have a really good, decent view. I can clearly see that those are 2 flutes. I can get a pretty good idea of the flute and condition and a nice 3-dimensional view. The other thing we can do is zoom back out and lower the microscope down to get a proper zoom in. So we'll lower it down. And here it can be helpful to rotate our fixture so that it's more easily pointed at one of the lights that we have. And again, that's really a very helpful and acceptable image quality, especially for the price point. You can see we have some debris on the tool. There is only one thing you want to use to get that stuff off there and clean the tool. It's the old bedroom wall poster putty stuff. We'll put a link for all this stuff in the NYC CNC page, but that is the way to clean off your end mills and not damage them. It does a really good job of getting lint or debris or dust off there. You can't use your fingers. We found this out from the Speroni. Your skin cells will just flake right off, especially at this high resolution. We just bought some 1mm drills. There's 3 of them in there. It's too small to rotate it in our fixture, so this time I'll just hold it by hand. And again, this is where other microscopes really fail. I found they're incredibly sensitive to a lack of focal range, so something's always out of focus, or you don't have a good 3-dimensional depth. And here, really not a problem to hold it steady enough, rotate it in your fingers, and get an idea of, again, what the cutting flute looks like, the edge quality, the condition of the drill. We use these 90-degree 2-flute or 4-flute mill drills. You can use them to spot, drill, chamfer, engrave, etc. But if you chip any of the flute point off, the height will be wrong, and thus the tool will be shorter, and you'll generally make a larger chamfer than you intend it to because there's a flat point spot on it. So you take that, lay it in our fixture, and you can easily get a very clear view, in this case, of where the tip of that tool has chipped off or been broken. In fact, right there is where the carbide fractured. We had some premature tap failure on our fixture plates and it was bothering me, so we sent a video and photo and email to the supplier, and it was awesome to have really good high quality video and photos to help them understand what may be going on. So again, same thing, just hand holding this tap, and you've got a really good image and 3-dimensional view of how that tap failed. And here's a screenshot of one of the PDFs from Sandvik that has some really good information on how to analyze insert failure, tool failure, coating failure, kind of read the tea leaves per se. And on that note, we use Sandvik drills to drill the holes for our fixture plates. It's a insert tip style drill, so there's a soft body that holds this tip, and we get a pretty specific tool life or hole life out of this tip, which we care a lot about because we'll drill 20 to 30,000 holes a month, and these tips are somewhere between 80 and 100 bucks. So same thing, we can use, I like to use one of these machinist toolmakers vices. You've got holes of different diameter. That'll let that insert hold itself up straight up and down quite easily. A quick focus. And here you can see we've got a minor amount of edge wear there, but it's the other side of that insert where we had kind of a critical failure. Where that failure occurs and the type of failure that is actually really important, either to you figuring out the problem or your tooling rep figuring out the problem. And whether it's adjusting your speeds and feeds, the rigidity, the workpiece, surface foot per minute, feed rate, all that stuff, really cool. And lastly, just in case it wasn't clear just how much you can zoom in with this, I thought I would show a postage stamp and a penny. So there's the year 2014 on that penny, but now if we zoom in a little optically by going closer, you can see there, and then again we can use the digital zooms if that's helpful. Same thing on postage stamps. Should be pretty easy to see the printing DPI to see how the postage stamps are actually printed. This should be kind of cool. I'm guessing these are CMYK printed. Anybody know? Actually, are they RGB or CMYK? But there you can see the actual printing colors on the stamp paper, which is pretty cool. So again, we've tried a bunch of different microscopes, including some ones that were multiple times more expensive than this. If you get one of these, again, you're gonna wanna print some sort of a fixture block or have a way to hold whatever you're trying to look at steady, or rotate the base or roll the object. We've actually found that the lights that are included with this are okay, but having either additional lights or lights with diffusers can also be something that really helps, as well as reduce potential glare. And then lastly, we have not modified this on its base, but that's probably the next thing I'll consider doing. We may move it either onto a giant Noga arm, which lets us move it around quite flexibly and rigidly, or I'll move it over onto this other microscope's traditional base. It's probably like a 50-pound weighted base that allows us a much greater range of motion, as well as to slide it out of the way when we don't want it. But the base is pretty rinky-dinky, but it hasn't really been a problem. We all use these on a pretty daily basis, and this microscope by far has been the one that makes us smile, because we really don't mind trying to quickly look at the edge of a flute of a tool to see if something is chipped. Heck, we can even look at the feed forward lines like we were doing in another Wednesday widget, trying to understand the inch per tooth feed rate of an end mill and what that means in terms of surface finish. Try to hold it in line. So really no problem at all. In fact, let me try to zoom a little closer on that. Yeah, no problem at all seeing the feed forward or scallop lines of an end mill on that part. So again, what you're gonna get out of this that you don't get out of the $80 or cheaper USB microscopes is actually pretty decent stereo or three-dimensional view. Other digital microscopes that we have tried have had really bad or poor refresh rates. They're very sensitive to the lighting, and thus there's a lag, which makes it very awkward to use and rotate. The fact that this has a built-in display, frankly, is pretty handy. What it's not good for is it's not the kind of microscope you're gonna wanna work under, especially for extended periods of time. So if you're doing PCB solder work or deburring work, you might be able to use this one, especially if you put it on a better base or a mount, but probably going to want to step up to one of like the Amscopes or trinocular style microscopes, but those can easily get to the $1,000 to $3,000 price point. So again, this is an awesome find. Anyone out there running a machine shop, I would highly suggest it. And if you can't afford this, go pick up one of the like $6 45X loops. Not the same as this, but it's still incredibly helpful in the shop. Hope you folks learned something. Hope you enjoyed. Take care. See you soon.